Hi guys, welcome back. I'm sorry for the abrupt interruption on the last video, but I realized that my notes looked a little different from yours from this point on, so I had to switch up. I grabbed the wrong one, old one. So I wanted to pick up on example 8 with you. I know this one is already done, but we'll go through this one together. So basically, we're going to talk about multiplicities now. So example 8 has you sketch the graph of this polynomial on your graphing calculator. So that's kind of what I did. I'd already done this ahead of time. So I plugged in this equation into my calculator if you want to do that. Okay, and then I hit graph to get what the graph looked like. And I know that I was going to have a 0 at -1 and at +3, and that's exactly what it shows. Except at -1, the graph goes through, it crosses the x-axis there, but at 3, notice it just touches and turns around and goes back up. So that's what we're going to talk about right now is the multiplicities. So I just sketched the graph on here like it asked me to. So I had a root at -1 and the graph went through it. And then at 3, it touched it and turned around. So we're going to use the word crosses when it goes through the x-axis, and we're going to use the word touches or touch when it turns itself around and does not go through the x-axis. Okay? So the way that we know this is what we call multiplicities. Depends on how many times the factor occurs. So you can see in our problem, the x plus 1 only occurred one time, but x minus 3 actually occurs twice, right? So that's called the multiplicity, 2. This one had a multiplicity of 1. Okay, so we were just looking at the exponent, so it's a very simple process. So at the bottom, we're going to fill this in, that when you have an even multiplicity, so you have a factor raised to some power k, in this definition, k is the multiplicity. So if it's an even multiplicity, your graph is going to touch at the x-axis at the root. And if you have an odd multiplicity, then your graph will cross. Okay? So that's what we're getting ready to do, is just look at some new problems that now incorporate these multiplicities for when we graph. Okay? All right. So let's look at example 9. It says use the graph of the polynomial function to answer these questions. So how many zeros does the function have? So where it's crossing the x-axis, those are your zeros. So this one has 4 zeros, right? 1, 2, 3, and 4. So we have 4 zeros in this problem. So the question asks, what is the possible degree of your function? Well, we know that it could be 4 if it has 4 zeros. That could be the power. However, since we have our n behaviors going in opposite direction, that means it has to be an odd degree. So that means that we would have to be at least 5, right? It would have to be at least an x to the 5th problem, because that could have 5 roots, but it doesn't have to. Okay, so it has to be at least x to the 4th. That would have been okay if both ends were going in the same direction, but because my ends are going in the opposite direction, I had to add one more to that. Could also be x to the 7th, could be x to the 9th. I don't know, but that's the first one that it couldn't be any less than that. Okay? All right, what is the sign of the leading coefficient? So right side down. So that means the leading coefficient has to be a negative number, right? So that right side always tells you that. List the zeros and whether each zero has an even or odd multiplicity. All right, so let's pick some numbers on here because that would be helpful, right? So there's 0. So let's say this is 1, 2. So let's that be -3. This could be +3, 4, 5, and let that be 6. Okay, so put in some numbers. So we'll just do -3 over here. Here's 0. Let that one be 3, and that one be 6. All right, so we have a 0 at -3. So x equals -3 is a 0. And since the graph goes through the x-axis, then that would have an odd multiplicity. Okay. Our next one would be x equals 0. That also goes through the x-axis at 0, so that would have to have an odd multiplicity. At 3, it touches, so that's an even multiplicity. And then at 6, the last one, it goes through the x-axis again, so that would also be odd. Okay, so now the question says, write a possible equation for the given polynomial function. All right, so remember the leading term has to be negative, and then we have to include all of these. So we could do f of x equals, pick any negative number. I'll just pick -2. You could do -1, but it has to be something negative, okay? And then we're going to list our zeros based on what we have. So we have x plus 3. Right, there's a root. The factor is x plus 3 because our root was -3. Odd, so I can keep it to the first power, or I could make it to the third power. Doesn't really matter. And then the next one would be x minus 0, which I'm going to go ahead and put in here, even though that's not the way we write it, but we'll change that in a minute. Then we have x minus 3. That's the root at 3. That has to have an even multiplicity, so 2. And then lastly, x minus 6. All right, and that could be odd. So your odd ones, you know, I could put a 3 there. It doesn't really matter, but typically we just do 1s and 2s, but it's fine if you do 3s or 4s, as long as it's the right odd or even number. All right, so the one thing I wanted to mention is that typically we don't write x minus 0, we just write x. But you don't typically put x in the middle of the factors. The x is always out front, right? So I would rewrite this as -2x, and then the x plus 3, then the x minus 3 squared, and then the x minus 6. Okay, that's the correct way to write it. So again, this is not wrong, that's okay, but just so you know, anytime there's a variable out front with x, that's a root of 0, right? You set that equal to 0, you get 0. All right. So number 10 says, what is a possible equation from this polynomial? So first off, if I'm looking at my n behaviors, it has to be an even degree polynomial. So my exponents have to add up to be some even number. Right side is up, so that means the leading coefficient has to be positive. And then I have my roots at -3. So I'm going to write at x equals -3. That's an odd multiplicity because it goes through, crosses. -1 is another 0, and it also has to be odd because it crosses. And then x equals 2 has to be an even number because it touches. So possible would be, remember the factors are the opposite signs of the root. So if the root is -3, the factor has to be x plus 3. Remember when you set that equal to 0 and solve it, it's going to give you the opposite number, right? Odd multiplicity, so I could keep that at 1. The next root was -1, so the factor would be x plus 1. And I'm going to make that to the third power, okay? And then we have x minus 2, and that has to be an even root for the root to be 2 there, okay? So the factor has to be x minus 2. Now look at your degrees. You have x to the first, x to the third, and x squared. So if you add those up, 3 plus 2 is 5, and then this 1 makes 6. That's an x to the 6th polynomial. The leading term has to be, or leading coefficient has to be positive. So 1 is fine there. You can put a 2 or a 3, it doesn't matter. As long as it's a positive one, that means the right side is up. Okay? All right. So let's move on to finding the X-intercepts and the Y-intercepts, all of which you guys know how to do. So this should be just a review, and then we're going to put it all together. All right, so to find the X-intercepts, which remember there's lots of words for that. You could be asked to find the zeros, the solutions, the roots. That all means the same thing. Where does the graph cross the x-axis? You set the function equal to 0. So that means you let y be 0, and then you factor. And then to get your zeros, you set each factor equal to 0, and you solve. To find the y-intercept, you let x be 0, and you solve for y. Or, back from part 1, remember at the very beginning, it said if your polynomial was in standard form, the y-intercept would be the constant term. So I know in example 11, my y-intercept will be 80, but I could let all the x's be 0 and solve that. I'll still get 80. So either way, you think about doing that. But that's only true for standard form, okay? If I give you this one for the y-intercept, then you would have to let all the x's equal 0 and solve that, because that's the only way to find the y-intercept there. Okay, so let's look at all of these and see how we do. We're going to do the leading term. The leading term would be the highest power you see, so that's x cubed. The degree would be the exponent of that term. And then I'm also going to write the leading coefficient. So the leading coefficient is 1, okay, which means it's a positive number, so that means the right side is up, okay? So I know the right side is up in this problem, and I know the left side is down because my degree is odd and the leading coefficient is positive. So there's my end behaviors on the graph. So the right side goes to positive infinity, left side goes to negative infinity. Okay, so for our x-intercepts, we have to factor, and the only way to factor 4 terms is to factor by grouping. So remember to group. The first 2 things get grouped together, and then these 2 get grouped together. But I need that negative 16, the negative to stay with the 16, so I'm going to put a plus sign right there and keep the negative inside the parentheses for a minute. So you're going to group the 2 together. Then you factor out what you can from each of these. So on the first term, I'm going to factor, or the first set, I'm going to factor out x squared. So that leaves you an x minus 5. And then over here, remember you never want a negative term first, so we're going to factor out not a 16, but we're going to factor out a negative 16. And if you divide both of these by negative 16, you're left with x minus 5. All right, so to group, these have to be the same. If they're the same, that's one of your factors. And then you're going to group the other 2 numbers together for the other factor. And then we can keep going now because that's a difference of squares. So my final factored form would be x plus 4, x minus 4. Okay? So now I can get my x-intercepts. You're going to set each of these equal to 0 and solve. So you're going to set x minus 5 equal to 0, solve that, you're going to get 5. Set x plus 4 equal to 0, solve that, you get negative 4. And set x minus 4 equal to 0, run out of room, and we get x equals 4. So there are your zeros, 5, negative 4, and 4. I'm going to put them in order from left to right. So I've got negative 4, 4, and 5. So I know here on my graph, here's negative 4, there's 4, and there's 5, okay? The y-intercept, remember you let all the x's be 0 and you solve for y. So if you let x be 0, that's 0. If you let x be 0, that term is 0. Let x be 0, that term is 0. So you're only left with 80 for the y-intercept. So I'm not, obviously, it's not to scale, but that's where your graph has to cross the x-axis. Okay. Now all of these have a multiplicity of 1, so all of these will just cross at those points. There's no touching on this problem. So we know we're going to start down here. We're going to cross through negative 4, and we have to touch at 80. Then we're going to go through 4. We're going to go through 5, and we have to end up back at the top. Okay. So again, this is not a perfect graph. It's not exact, but that's the shape of what you would have. Okay. All right, so let's try that again with example 12. All right, so for this one, we have to go back to what we did on the front. We have to find the leading term, so we got to do some multiplying. So the leading term, we would take each of the first terms, including the exponent. So negative 8x, this term would just be x. This first term would be x squared. And the last term would be 2x. So that multiply all that together, that'll give you your leading term. So negative 8 times 2 is negative 16. Add your exponents, so 1, 2, 3, 4, 5, so that's x to the 5th. All right, so the degree is 5. The leading term is negative, so that means right side down. And if the right side is down, then the left side has to be up if our degrees are odd. Okay. So there's your end behavior. The x-intercepts on this one are easier because I just have to take each factor and set those equal to 0. So if you set negative 8x equal to 0, solve that by dividing by negative 8, you get 0. Set x minus 1 equal to 0, solve that, you get 1. Set x plus 3 equal to 0, get negative 3. And set 2x plus 7 equal to 0, Move the 7 over, it's negative, and divide by 2. So negative 7 halves. Now, all of them have a multiplicity of 1 except for x plus 3. So this one will touch, but the rest of them, this one, and that one will cross, right? So the only one that's going to touch is that. The rest go through. Your y-intercept on this one, you're going to have to let everything be, all the x's be 0. But right here, you're going to get negative 8 times 0, right? So negative 8 times 0 is 0. Doesn't matter what these are because 0 times anything will still be 0, right? Let all of those equal 0, and that would give you your y-intercept. So y-intercept is 0, and that was also an x-intercept, so that takes care of both of those. I have a root at 1. I have one at negative 3. And then negative 7 halves is negative 3 1/2, so here's negative 4. So right here's another root, okay? All right, I'm gonna move my arrow over. So I'm going to only touch at negative 3, and I have a start up here. So I'm going to start here, go through, touch, okay? I'm going to come back. I got to go through here, and I got to go through here. Sometimes my arrows don't line up, but tell me where I got to start and end. All right, so go through, we touched here, and then through and through, okay? So there's a graph again, not exact, but close. All right, so the last topic on here are the inequalities. So we're basically going to use what we did from before, but we're going to take away the y-axis. And instead of, x, we're just showing you that obviously if you go to the right, that's positive infinity and left. So we're going to do the same graph, but without the y-axis, okay? So we have a root at negative 1, 2, and 5, right? You said each of those equal to 0. That'll give us our roots. So negative 1, 2, and 5. We're going to touch at negative 1, cross and cross. And the degree of this polynomial, count your exponents. So 2, 3, 4. So that means the right side's up and the left side's up. Leading coefficient is, all those numbers are positive. So the right side's up and so is the left. So we're going to touch at negative 1. Okay. We're going to cross at 2. And we're going to cross at 5. So there's what the graph looks like. Now, remember, these are the zeros. That's where your function equals 0. So I'm going to put that over here. The function equals 0 only at those 3 points. So we're getting ready to do inequalities, so we're looking at where the function is greater than or less than 0. So above the x-axis, all these numbers up here are positive, so this is where the function is greater than 0, all of that up there. And then anything below the x-axis is where your function is less than 0. Okay, because remember, that's the y values, and we took away the y-axis, but still, anything above the x-axis, those are positive numbers for y. All right, so now when you answer the questions on an inequality, you're just going to take the same sketch we've been doing and just look for the top or the bottom parts of the graph. So for part A, it says, where is the function less than 0? So that would be down here, and you're going to give an interval, so it's all the numbers between 2 and 5. But you're not going to include 2 and 5 because that equals 0, and this is just less than 0. So I'm going to skip B for a minute, so look at part C. The difference between these is this one you are allowed to use where it touches the x-axis because that's where it's equal to 0. So less than or equal to 0 would be between 2 and 5 this way. Okay? All right, now, here a little bit different. So the first one's asking you where is the function greater than 0. So all of this and then this, but you can't use negative 1 and you can't use 2 and you cannot use 5. So I can't just go from negative infinity to 2. I got to take this number out because I'm just doing greater than. So that would be negative infinity to negative 1. And then everything between negative 1 and 2. And then everything bigger than 5. Right? Okay. However, on this one, where you can be greater than or equal to 0, I can include that. So then I can go from negative infinity all the way till I get to 2, because everything is part of that. So that would be, negative infinity to 2. And then I could pick back up at 5, and I can include 5. Okay, so notice that these look different. So, it's not always just a matter of changing from parentheses to brackets. Sometimes it changes your answer altogether. Okay. All right, so that was already given to us. So the last problems we're just going to have to solve. So at the bottom of this page are your steps to solving. Okay, so if you look at step 1, that is the most important step, and that is that your function has to be on the left side and that your 0 value has to be on the right. Okay. All right. Now, the rest of the steps, basically what we just did, we're going to factor and find the real zeros. Then we're going to use the zeros and divide up our x-axis, and then we're going to sketch the graph using the end behavior and everything. And then we're going to find whether we're going positive above the x-axis or negative less than. We're going to go below. Okay? All right. So let's look at a couple of those, and then we'll be done. All right, so solve this inequality. So again, the very first step, which is the most important, is you have to have the function on the left. So we're going to move the 9x over, and 0 has to be on the right. If you do that the other way, then you're going to get your problem backwards and your answers will be wrong. So always on the left. All right, so we're going to factor that. Factor out an x. Leaves you x squared minus 9. This can keep going, so that's a difference of squares, x plus 3, x minus 3. Okay, all of these have a multiplicity of 1. So we're going to have a root at 0, at negative 3, and at 3. Right? Set each of those equal to 0 and solve. So negative 3, 0, and 3. This was a cubic, x to the 3rd, so the right side's up because the leading coefficient is positive. And the left side's going to be down because that's an odd degree, right? So there's my end behavior. And we're just going through these points. So we're going to go through here, through here, through there. Okay? All right, so this is where your graph equals 0. This up here is where your graph is greater than 0, and down here less than. So go back to your problem. You want to know where your graph is less than 0. So that would be only from negative infinity to negative 3 and 0 to 3. And do not include those numbers. Okay? So negative infinity to negative 3 and then 0 to 3. All right, so for part B, same problem, right? Except less than or equal to. So I don't need to do another graph of that. It's the same graph. Okay, same problem, except now we get to include those values as well. So that would be from negative infinity to 3. Sorry, negative 3, and I'd get to include it. And then 0 to 3, and I would get to include those. So that one didn't change much other than just the parentheses changed to brackets. Okay, sometimes that happens and sometimes you got to change it up a little bit. Okay, last one, solve this inequality. So I need to move these two numbers over here. So x squared and the 5x are going to stay where they are. 3 has to come over, it'll become minus. X squared has to come over, it'll become positive, and there's my 0. I can add the 2 x squared plus x squared to get 2x squared. And then this I just have to factor. This is a quadratic, so I know it'll look like a U, right? So factor. So in the first two spots, I have to get 2x squared. So now my problem is, do I put the 3 there and the 1 there, or the 1 there and the 3 there? So I need to get a difference of 5. Subtract to get 5. So that means I want the 3 here and the 1 there. If you put them in the other way, you would add to get 5, but that's not how I'm going to get this, because these signs have to be different. In order to get -3, one of these has to be plus and one of these has to be minus. And it has to go that way. And remember, when you guys do this, if you're still struggling, just FOIL this out and make sure you get what you started with. So first would be 2x squared. That's right. Outer is a positive 6x. And the inside one is -1x, which gives me positive 5x. And then -1 times positive 3 is -3. There's only one way to get back the way you started. So if you have your signs wrong, or if you have the 3 and the 1 in the wrong place, you will not get that when you multiply it out. So it's a good idea to check if you're not feeling too confident on your factoring skills. All right, so again, each of these have a multiplicity of 1, so they're just going to cross. Set each of those equal to 0. So over here, you're going to get 2x equals 1. So you should end up with 1/2, right? And then over here, set that equal to 0, you get -3. All right, so on my number line, I just have -3, and I have 1/2. Those are the zeros. And then this is a positive leading coefficient, right side up, and even exponent, so both sides are up. So they're just going to cross like that. All right. Okay, and I need to know, where is this graph just greater than 0? So not including those. So they're greater than 0 over here. So that's -infinity to -3. And then it's also greater than 0 over here. So that's 1/2 to positive. Okay. So pay close attention to the symbol, and then again, just be careful when you're writing your inequality that it works with what you have as your picture. All right, so that does it for the rest of section 5.1. So you guys let me know if you need any help. Otherwise, get started on the homework, and I'll see you back here next time.